Hello, dear friends. Today I am going to explain to you how to determine the sample size. That means you got a population. From that, you are going to select some samples. How to determine the size of the sample. So that's what we are going to learn today. And this is based on a paper by Glenn D. Israel. The title of the paper is Determining the Sample Size. Okay, so you got a population, and now you are going to select some samples from the population. How to determine that? So it will various factors are going to affect this, like sampling error or level of precision. The sampling error is called level of precision, then the confidence level and degree of variability. So I'll tell you one by one. So what is meant by the level of precision or sampling error? So the explanation is a sampling error is a statistical error that occurs when an analyst does not select a sample that represents the entire population of data, and the results found in the sample do not represent the results that would be obtained from the entire population. That means now when you select the sample, you are not going to select the entire population. So you cannot say the what you selected will represent the population completely. That's the meaning of this. So sampling error is a statistical error that occurs when an analyst does not select a sample that represents the entire population of data. The results found in the sample thus do not represent the results that would be obtained from the entire population. And sampling error can be reduced by randomizing sample selection and or increasing the number of observations. These are the points that you should keep in mind while dealing with sampling error. That means basically it is because you are not taking the entire population. So some errors will be associated, and that is known as a sampling error. How you can reduce? Either you can increase the number of observations. That means you can, if you go for taking the maximum samples that way, or otherwise by randomizing the sample selection. Okay, by making it more randomized. And next comes next criteria, that is confidence level. That means you will be knowing the 95% confidence level, 90% confidence level. So what does that mean? So if the meaning is this, if you were to repeat your survey over and over, survey means sampling, survey over and over, 90% of the time you would get the same results. That's the meaning of 90% confidence level. So 90% of the time you would get the same results, and it is associated with the central limit theorem. That is, the confidence level or risk level is based on ideas encompassed under the central limit theorem. What does the central limit theorem says? The key idea encompassed in the central limit theorem is that when a population is repeatedly sampled, the average value of the attribute obtained by those samples is equal to the true population value. So as you increase the as you increase the size of the samples, or in other way, when a population repeatedly sampled, then the attributes associated, that the mean or standard deviation associated with the sample will be that of the true population. In other words, this means that if a 95% confidence level is selected, 95 out of 100 samples will have the true population value. Okay, so 95% means 95 out of 100 samples will have the true population value, that is associated with the population's attributes, that the population average mu will be, and 95 out of 100 will have their average as the mu. and next is degree of variability. So that means variance associated with the sample of population, whether the data is homogeneous or heterogeneous. What is homogeneous means? I mean, it is more or less related. The data set is more or less related. Suppose you are taking, say, you are taking the physics mark of youth of age 21. So your data set is containing that mark of the mark of youth with age 21. That is homogeneous. What is heterogeneous? The mark of the youth from age 13 to 21 of physics, maths, biology. So that data set is heterogeneous. So how to deal with that? If the heterogeneous population, then the sample size must be large, and if it is homogeneous, you can have a small sample size. This is what you have to understand regarding degree of variability. The third criterion, the degree of variability in the attributes being measured, refers to the distribution of attributes in the population. The more heterogeneous a population, the larger the sample size required to obtain a given level of precision. The less variable, that means more homogeneous a population, the smaller the sample size. Okay. Now, how to determine, what are the strategies associated with determining the sample size? The first strategy is use a census. That means if your population size is small, take the entire population for your study. That is the sample size and the population size same. That you can do only when you're dealing with a small population. Census means it is covering the entire population. So if it is small population, you can use the census. Okay, that's the first one. Second is you do a literature survey and see a sample study or a similar study before and take the sample size from that. But then the algorithm or procedures adopted in that paper should be same of that what you are going to use. Then only you can take the same sample size. And the next one is using published tables. Some leading universities has published. Suppose you are taking 20,000 population. What should be this is the thing, size of the sample size, it is given. Suppose size of the population is this much, and the level of precision is plus or minus 3%. Then how much should be size? And then you can see here. So suppose it is 100. Then you should take 81. So published tables are there in some websites. So for a population, how much should be your sample size? You can do that method also. And then there are formulas to calculate the sample size. So one formula is called Cochran formula. This is the formula of Cochran formula. The N0 equal to Z square by PQ by E square. So Z here is a Z score. P is the probability value. Okay. So if you don't know the probability, and if you are giving maximum variability, you give it as 0.5. Okay, here they tell a maximum variability. In one example, they are taken here as 0.5. If it is not given, you take it as 0.5. So P is 0.5 means Q will be 1 minus P, and E is the level of precision or error given. Okay, so precision, level of precision is the E. So in this example, N0 is equal to Z square into P into Q by E square. Substitute the values, you get a 385 farmers. So you get a 385 farmers, and here you should know P and Q. And suppose you don't know P and Q, there's one another formula known as Yamane in that you can calculate n equal to n is a, so n0 here, here n0 is a sample size, here n is a sample size, and capital N is the population size, n by 1 plus n divided by 1 plus n into e all square. E is the level of precision or error. Okay, so in this example you will get n population size is 2000, so 2000 divided by 1 plus 2000 into 0.5 0.05 all square, and 333 formats. This is how you set. There are different methods to select sample size. So these are the main strategies. You can see this is how you determine the number of samples to be taken or sample size. Hope you understood. Thank you. In Excel also you can select sample size from a population. I forgot to mention that. Suppose you have got this many data with you. I had used some methods and copied here, and you want to select samples from this. Go to data, take data analysis, sampling, select here. So you have to select your data, and here two methods are there. Either periodic, so you want to give a period here. You give period some 10, and then you give output range, and this one take OK. So you suppose you take an interval or period, then these are the data. This is the values you are getting from this. And suppose you are going for random, you can see random. Then you have to give number of samples you need. You are giving 40, and you are giving okay, you'll get 40 samples randomly selected. Okay, but the problem is that here the number of sample size that you have to give from your side, either by giving the period size or by number of rand. As you can see here, you have to give that. That's a problem with the, either you have to give the periodic or period interval, or you have to give number of samples that you have to give. Then only you'll get a sample. That's the problem associated with the system. Okay, thank you. Hope you understood.